Hello, everybody, everyone. Okay. This is a short clip is talking about how to calculate the centroid of composite area. Okay. And I want to show you more example of the centroid calculation. Yeah, so this video I just go into the example. So this video don't cover any central explanation. Okay, if you want to know the central, the fundamental of central concept, go to see other video. Okay, this video I'm going to show you the left-hand side example. Left-hand side example. Find the centroid of this composite area or composite bodies. Okay, so when it comes to the composite area or composite body, okay, we just in class, I told you, okay, first of all, treat the composite area as a combination of a simple area. Okay, so let's see. Okay, I think I should copy this to, let's make the whole area clean. Okay, okay, so. Okay, how to calculate the centroid of this composite area? Okay, so this is a composite area. Okay, what's the combin? Can we simplify this shape as the combination of simple shape? Yes, it is. Okay, it is sure it does. Okay, because this composite area can be viewed as the combination of a right triangle and a half and a semicircle area. Okay, so sure. Let's see. What choice? What should I use? Use. Okay. So this area is like a combination of the. Uh, sorry, I cannot. I don't have ruler, so I cannot draw a very fancy picture by the pad. Okay, so. Uh, is equal to right triangle plus the semicircular area. Okay, so that's the first step of the first step for the calculation of centroid for the composite area. Okay, treat the complex shape or area as a combination of simple shape. Okay, so right triangle and this problem right triangle and the semicircle. Okay, so and the next thing is okay. Try to find the triangle of each part. Try to find a try to find the centroid of each part. Okay, so for this one, so we need to find the centroid of this right triangle and the centroid of this the semicircle. Okay, so okay, let's say let's say the right triangle. I call it area one, and area one. Okay, and in the semicircle, I call it area two. Area two. Okay, so we have the area one and area two. Okay, and but first of all, I think we should also calculate the area of each part. So the area each part for this one, okay, this is a right triangle. I think the area of right triangle is very easy for everyone, right? So this is radius is 3, so this is 3, this is 3, so the area is 9. 9 times 6 divided by 2. Okay, and what's the value of it? Yeah, it's 27. Okay, and what's the area of this? What's the area for the area 2? So it's a it's a semicircle. So it's 1/2 pi r squared, and r is 3. Okay, so don't forget a square. So the value is let me see. It's about 14.13. Okay, and it's meter square. Okay, so and okay, next thing, okay, that's what I just say is find the centroid of each part, and this is 2D system, so we have the x coordinate and y coordinate. Okay, find the Okay, so what's the coordinate of this right triangle in this coordinate system? Okay, so where is the centroid? Okay, the centroid of a right triangle. I just introduced them in several videos ago. So here I don't want to talk from the very beginning. I just jump into the conclusion. So where is the centroid of this right triangle? Okay, yeah. Remember, I think it's here. Okay, here, right here, and this is 1/3, and this is 1/3. Yeah, remember that? Remember that? So the centroid, I think it's about here. So the distance here is 3, and the distance here is how many? Distance here is this is 6. So here the distance here is 2. Is 2. Okay, so the centroid of the triangle, you need to memorize the conclusion. Yeah, yeah, because it's easy to memorize that. Right. Okay. So what's the coordinate of the centroid of this right triangle in this coordinate system? What's the x coordinate? Okay, don't forget the origin is here. So the x coordinate, I think, is let's say that I write it too long. Okay, this should be. I think this should be short. Uh, this should be. I think it's here. This is 2, and I erase this. Okay. So here, so the central is here. X coordinate is here is 2, and the y coordinate is 3. No, oh no, here is 3. But in this coordinate system, here is 6. So the coordinate of this centroid is and 2, and this is 6. Okay, this is 2, 6. Okay, okay. Is that okay? Okay. And the other thing is the centroid of the semicircle. Okay, the centroid of semicircle, you can look up the table. Okay, okay, and let me just temporarily switch this off. Okay, okay. So actually, for the centroid of a semicircle or quarter circle, you can look up the table. Okay, the centroid of a semicircle area is here. This is the formula. Okay, it's right at the center. The y is right on. Yeah, it's right on the center. Not a center. It's just yeah, it's not center. Okay, okay. It is lie on the y-axis. Lie on y-axis. Okay, right on the y-axis, and the distance from the x-axis is 4r/3 pi. 4r/3 pi. R is the radius of this semicircle area. Okay, so back to this problem. Okay, so back to this problem. What is the coordinate of the semicircle area? Okay, so the semicircle, I think the centroid, I think it's right here. It's right here. Sorry. Yeah, it's right here. And the next thing is what is the coordinate? Okay, we just know the distance here. Okay, the small distance here is 3 pi 4r. Okay, so the distance here is okay. Okay, let's back. So we have to be careful because we need to know the coordinate, coordinate of the centroid of the semicircle area under this coordinate system. Okay, so the x coordinate is here. X coordinate is here, and I think that this and here I think the distance is 3. The distance is 3. Okay, x coordinate is 3. X is 3. And what is the coordinate of y? Okay, it's the centroid of the semicircle circle area is here. So here is 9. Here is 9. And the 9, we have to add the distance here. Okay, here is 4r/3 pi. So it's 9 plus 4r/3 pi. R is the radius, so it's 4 times 3 divided by 3 pi. Okay, so what's the value of this? Let me check. Yeah, it's maybe it's 10 to 10.27. Okay. So we finished the second part of this composite area calculation for the centroid. Okay, first of all, treat the composite area as a combination of the simple shape. Okay, and then find the centroid of each find the centroid of each part. And then when do the area average. Okay, so the area average is area average is okay. So x is equal to, let's call a1 plus a2 a1. So this is x1 plus a2 x2. And y here should be a1 plus a2, then a1 y1 plus a2 y2. Okay, so we can plug everything. We, I, we can lump every lots of number in there. So I don't have space here. So x is equal to, what's area 1? 27 plus 14.13. And 27 times the x is 1 is 2 plus 14.13 times 3. And the y bar is 27 plus 14.13 is 27 times is 6.13. This is too close. It's not good. Okay, sorry. This is not good. Maybe I should write here. This y bar is 27 plus 14.13. 27 times 6 plus 14.13 times this is 10.27. Okay. And then use your engineering calculator or calculator. I think the answer should be, let me see, stapler should be 2.34 here, and the other is 7.47. And don't forget the unit. The unit here is meter. Okay. Okay, so this is also a very fundamental example for calculate the centroid of the composite area. Okay, so treat the composite area as a combination of simple shape, and then calculate centroid of each part. Then doing the area average, and then you can find the coordinate of centroid very easily. Okay, so. And this type of calculation is very fundamental in mechanics of material. I hope everyone should know about this. Okay, so here is I just stop the video here, and next video I will show another example of the finding the centroid of composite area. Okay, see you the other video. Bye bye. Where should I stop?